So if you don't know about this series, this is most probably the only series throughout the internet which is about the detailed solution of real BARC previous interview question. Yes, you can find almost everywhere, starting from Quora to YouTube videos, the real BRC interview questions. But I am sure, I guarantee that you will never find, you will not find in anywhere this much detailed solution of those questions. I have already published 3 videos about the same of heat transfer, fluid mechanics, and strength of materials. And you can check out in a playlist called Interview Logic Building series in my channel. So this video is another one. And hey, how was your BARC examination? I hope it was good, and all the best for your further interview preparation, for which this video series is a must. So without ado, let me start. So firstly, see, this question I have actually posted a few days ago in my YouTube channel in the community post. Now this is a question of heat transfer asked in 2020. Now this says that I have 3 objects, two spheres, one of radius r, another of 2r, another is a cube having the same mass as that of this sphere having radius r. Fine. All all of these are having the same initial temperature at 100 degrees Celsius, and they are kept in a same surrounding of air, having air at 30 degrees Celsius. Now you have to draw the time versus temperature, or I should say temperature versus time graph for all these 3 in the same TT plane, capital T small t plane. It should be actually capital T small t plane. Okay, because small t will be the x-axis and capital T will be the y-axis. Now here, I know that most of us have the tendency that we will try to derive the equation. And we also know that there is something called a lumped mass analysis, right? In the lumped mass analysis, what we do exactly? In the lumped mass analysis, we neglect the variation of temperature inside the object. We neglect the variation of temperature inside the object. We assume that at any time point, at any instant, the temperature throughout the body is constant. We assume these things. And to assume that, we have a number, non-dimensional number called the bio number. So they can ask you the significance of the bio number also. But here, if you try to derive that equation, or in the first place, if you write that formula, then my friend, you will be in a really big trouble, unless otherwise you have a very depth or you have a very deep understanding. Okay. So the challenge is that you can't use any sophisticated equation. Obviously, you can use basic equations, and you have to draw by your intuition and basic physics. What do you mean by basic physics? So if a class 12 student can also draw, or he or she can also understand this thing very much. So I mean, in other words, those equations, those lumped mass analysis involved calculus. So I ask you to solve this without using any calculus. Okay, the basic understanding of your physics of the heat transfer. Okay. Now I would suggest you to pause the video and try it by yourself. And I hope that you have tried. Now I will be solving this. So firstly, let me draw the TT plane. So, okay, I am satisfied with the lines, and this is my time, and this is my temperature. So all of them are having a same temperature, that is 100 degrees Celsius. Okay. Now firstly, you have to understand that the heat transfer is actually dependent on the temperature difference on the of the 2 bodies between which the heat transfer is taking place. Now here the heat transfer is taking place between the objects and the surroundings. So you have to consider the temperature difference between the object and the surrounding. Now, the more is the temperature difference, the more will be the heat transfer. The faster will be the heat transfer, right? For example, if you have a very hot thing, and if you just grab that thing in your hand, then it will feel very hot, that this is very hot. And I mean, essentially, the heat will be transfer to your body from that object very fast, because the temperature difference between your hand and that object is very high. So, okay. So this thing is the first thing that you have to understand, that the more is the temperature difference, faster will be the heat transfer. So there is no rocket science. This is I have told from our basic understanding of physics. And these things are what they expect from you in the BARC interview. Okay. Now, let us say that at a particular time at zero, at time t equal to 0, the object was at 100 degrees Celsius. Now, at a particular time, maybe at a time of t equal to delta t, okay. Now, my temperature of the object will obviously decrease, right? So, maybe this is 90 degrees Celsius. Okay. So, initially I was having this point. Now, I will have actually this point. Okay. This was my, this will be my second point. So, now you have to understand that initially the temperature difference was 100 minus 30, that is 70. Now the temperature difference is 90 minus 30, that is 60. So after a particular time, the temperature difference is decreasing. After a particular time, it will be maybe 40, and it will, ideally at the infinite time point, it will go to 0. The temperature difference will go to 0. Clear? So now that means the rate of heat transfer, that will decrease with time, because the temperature difference between the object and the surrounding, that is decreasing. Clear? This is the key point to draw the nature of the curve. Because see, all of us know that okay, the temperature will decrease, and after a particular time point at the end, it will end up with being at a surrounding temperature, that we all know. But now, if this is my surrounding temperature 30 degrees Celsius, now I can draw a curve like this. Okay, maybe this will be my curve. Okay, so in this curve also the temperature is decreasing with time, and at a particular time it has reached the 30 degrees Celsius point. But this is not right. This is not right. Because why it is not right? Because at any point, the rate of change of temperature is same. At any time point, the rate of change of temperature is same. Now, another curve I can draw like this. In this curve also, if this is my curve 1 and this is my curve 2, so in curve 2 also, the temperature is decreasing with time. Okay. But now you can see that the slope, these things are the slope. The slope is increasing with time. That is impossible. So this curve is also not possible. You have to draw a curve which shows the decrement in the slope of the curve, because the slope of the curve is indicating the heat transfer rate. The faster the heat transfer, the faster the temperature will decrease. Okay. So that means I have to draw a curve which will denote a decrease in slope. Okay. So this is from the basic understanding. Clear? So that means I have the option to draw the curve like this. Okay. So this will be the answer, and obviously this will pass through this point, but this will be very untidy if I draw all these things. So let me just remove them. Okay, okay, this line should be there. Okay, it should be asymptotic. Another fact is that they should be ideally asymptotic. I mean, you should not touch this thing with this 30-degree line. And let me make this 30-degree line dotted, because this is just an imaginary line with respect to the graph. Clear? So, this can be the temperature variation for any of them. Okay, I have 3 bodies. So, among the 3 bodies, this can be the variation for any of them. Okay, for any one of them, we don't know. So, for the time being, let me assume that this is the temperature distribution for the sphere having radius r. Having radius r. Okay. So I will denote it by a circle, a field circle R. Okay. So now the question is that what will be 2R? I mean, what will be the graph for this 2R and what will be the graph for this Q? So first of all, the nature will be exactly same and the initial and the final points will also be exactly same. So I can have, so now let me take the case for the 2R wala sphere. Okay, so I can have this kind of a graph or this kind of a graph. Which one will be true? Having the same nature, but one is above this graph, another is below this graph. So which one will be true? Again, pause the video and first try by yourself. So now if you have already tried it, now let me give you the logic. Okay. So you see that if you have something with a very large volume, that means it can store a large amount of heat. And the heat transfer is actually taking place from the surface. So if the surface area is more and more heat will be transferred. And if the volume is more, it has the capacity to store the heat. It has the capacity of store the heat if it is having a very large volume. And if the surface area is more, then the heat transfer rate is more. So that means these two are actually opposing each other. If the volume is more, then the heat, the capacity to hold heat will be more. And if the surface area will be more, then the capacity of losing heat, that will be more. So that means if my volume is more, my time of temperature decreasing, that will be more. I think that you are might be a bit confused. So think it like this. I have a large volume. I can hold a lot of heat. So I will not let go the heat out of me. Okay. That means to come the, I mean, to come at the point of 30 degrees Celsius from 100 degrees Celsius, I will have a large amount of time because I will not let go the heat away from me. So the more is the volume, the more time it would require to decrease the heat, to decrease the content of it or to decrease the temperature. The more is the surface area, the lesser will be the time. Okay. So that means V by A, volume by area. This is the ratio that will be actually a function. Okay. And I can say that this will be proportional to T. Okay. Because 1 by A, because A is proportional to 1 by T and B is proportional to T. Okay. Or in other words, 1 by A is proportional to T. So it can be proportional to T square, it can be proportional to T cube. So in manufacturing, we have a rule called Shorinov's rule. And that actually takes care of the same thing. So see, we have actually the connection between different subjects, and that we have to find out. If we want to be real scientists, if we want to be real engineers, then we have to think or we have to see a practical real life problem from an integrated point of view. You can't say that I am a mechanical engineer and I will not study electric vehicle. Okay. You are an engineer. That is okay. Okay. You have to accept that, okay, this is a real life problem. I have to find a solution. That is a job of an engineer. Okay. So now that means if we know this, now this V by A for a sphere again is proportional to R, the radius. That means the more is the radius, more it will take time to reach to a lower temperature, right? That means the graph will be like this. So at a particular temperature, so now I will show, okay, so this is a sphere of 2R. Okay, so I will just remove this notation and I will draw it with this color. This is a sphere with R. Okay, So you can see that at a particular time point, the sphere with 2R is having more temperature. Okay. Now, what about the cube? Now, the cube is having a mass that is same with this smaller sphere. That is same with this smaller sphere. Now, you tell me that, okay, now you know that you have to find the ratio of V by A. So, okay, you are now done. So, you can do this on the board also, but they expect you to know that for us, I mean, for two objects having same mass, if one is spherical and another is cubical, then the surface area will be more for the spherical thing, for the cubical thing. Why? Because if if two objects are having same volume and here they have told it is having same mass, so I can consider that they are made of same materials. Okay, otherwise this question does not have any meaning, because if the material changes, then the nature will always change. Okay, because on the material also it will depend. Clear? Now, if they are of the same material, that means same mass means same volume. So if two objects are having same volume, but one is cubical and another is spherical, the sphere will always have the least surface area. That means the V by A will be more for this one. V by A will be more for this one. Which? This one. Okay, because it has a smaller surface area. It will lose heat. It will lose it slowly. And these two are having same amount of volume. Okay, another interesting thing. See, these two, if we, I mean, compare these two, this is having a larger surface area. But at the same time, this is having a larger volume also. So if I consider the volume, then this this wins. I mean, this will be cooled faster. Okay, because volume by area. So had it been that the volume by area is 1 by R, then this would win. Okay. So now we know that the cube will take lesser amount of time than R. Okay. So if I have to draw the cube, so okay, I will draw the cube with the black. So something like this. Now this will be a cube. Okay. Cube. So I am denoting it with a square. So this will be the answer here. Okay. Now in this video, I will solve. Okay. Firstly, I will give you a homework. Okay. I will not solve this now. I will solve this in the next lecture. Okay. So this is a problem for fluid mechanics, and if you are going to BARC, then tank filling or tank emptying is the problem that you can surely expect. So these kind of problems are their favorite. Okay. So I will have a tank. So with this tank thing only, I mean tank filling or tank emptying, they can actually make thousands, I mean infinite number of problems. They can alter the situation. Okay, one by one. So now I am having a tank, rigid tank. Okay, rigid tank, and in this tank I have two holes. One is here, another is here. Okay, so this hole, should draw it with this color. This is a hole and this is a hole, and the height between these two holes are given here. So this is another hole. So this height is given. So this height is capital H. Clear? Now it is given that with a velocity, okay, or with a volume flow rate of Q, water is entering. Oh, okay, I should draw it. With a volume flow rate of Q, water is entering. Okay. Now this H is the difference of height between these two holes. Now you have to draw the H versus time, or small h versus time rather, where the small h is, okay, this height. So this is the, I mean, water level, and I should change the color for these things, I guess. So this is the water level. Okay. So this height is h. This height is h. And for your sake of understanding, I am saying that this height you can actually neglect this height. Clear? So now you have to draw h by t. Draw h versus t. Obviously by your intuition and basics. Okay, intuition. Now you can use some basic formulae, okay, but you don't have to use any kind of rocket science. Okay, so draw h versus t. This is one tank problem which I will solve in the next lecture, and like this I will bring so many tank problems. Okay, until that, all the best for your interview preparation. Goodbye, take care, and thank you. And please subscribe to my channel if you feel, only if you feel, that this guy is trying to do something for you. And I apologize that throughout this month, I haven't brought anything for gate preparation, anything for fall, anything for personal development because I was a bit sick. Okay, I was having a prolonged health issue, and because of that, I I mean could not make those kind of videos because generally those kind of videos a bit long. Okay, so, but now from the 17th of March, on the 17th of March, you will be getting the 1 year preparation strategy unique to your situation for GATE 2026. After that, I have planned so many videos like that. And don't worry, this series will not stop at all. And I have also planned some consultancy sessions. But obviously, let's see, I don't have that much time. I don't have, that much time and very hectic schedule. So obviously, these sessions will be paid. Clear? So consultancy sessions, and other than that, mock interviews for BARC, DRDO, ISRO, IITs, and IISc M.Techs. Okay. So obviously, I will try to make the pricing as low as possible. Okay. So I will meet you in person, and obviously 1:1. Okay. And if time does not permit, so maybe I will take uh, two aspirants or at most three, but not more than three. But obviously, then the price will reduce. So I will meet you in those videos. And until that, goodbye, take care, and thank you.